Okay, this one is interesting because I actually have a functions inside of a function. So let's start by saying I need to find the value of h of 5, which means I need to take this 5 and put it in place of every x in function h. So I look at h of x and replace every x with a 5. So this becomes a 5, and this becomes a 5. And that becomes a negative 2 f of 3 plus 2 g of 6. So negative 2 f of 3 plus 2 g of 6, like that. Now what I need to do is I need to solve some things. So if I have f of 3 there, f of 3 equals 3 minus 1, because I have to plug the 3 into this equation for f. So f of 3 would equal to 2. And then I have to plug this, to find g of 6, I have to use this equation up here and plug the 6 into there. So that means I would have g of 6 would be equal to negative 5 times 6. That's a little special so far. That would be negative 30. Now for my last trick, I'm going to take these numbers here, the 2 and the negative 30, and substitute them back in. I know f of 3 is actually a 2, so I have negative 2 times 2 plus 2, and I know g of 6 is actually a negative 30, so 2 times negative 30. So then what I end up with is a negative 4 plus negative 60 is negative 64. And that's what I end up with on this particular equation. We're going to work through one more of these, and hopefully I'll be able to show you how to do something with DeltaMath. So to find h of 2, start by taking the 2 and replacing everything in equation h, all the x's. And that's going to give me 3 f of 3 minus g of 2. Now to find out what f of 3 is, I'm going to substitute into this equation here with the 3 where the x is. So that means f of 3 would be equal to negative 3 times 3, which is negative 9. Then, when I'm looking for g of 2, I'm going to substitute into this equation here with my 2. So I could say g of 2 would be equal to 2 plus 3, which is 5. So I've got to get rid of this and put a 3. I have to get rid of this and put a 5. So 3 times 3 minus 5. 3 times 3 is 9, minus 5 is 4. So I have an answer of 4. Now, I'm going to show you how to do something with DeltaMath on this. Another neat thing you can do, hopefully you can do these without using Desmos, but if you type all those equations in Desmos, you can make progress. So I need to start with f of x equals negative 3x, and g of x equals, I think it was an x plus something, an x plus 3. And then I do have to type in h of x as well. H of x is equal to, let's see, 3 f of x plus 1. It keeps graphing these things. You can kind of ignore the graphs. We don't need them too much for this problem, but you can look at them for fun. Minus g of x. Now, what I'm concerned about is h of x, and I'm looking for the value of h of x when it is equal to 2. So like we did before, I can turn on a table for h of x, and I can look for the value of 2, which gives me 32, and if negative 32. So if you go, that causes me some concern because it didn't match my answer. So I'm going to go back and check my work. And when I do, I notice I made a simple substitution mistake. F of 3 was not equal to 3 as I put down there. F of 3 was actually equal to negative 9. So if I make that a negative 9, what I'm going to have is a negative 27 minus 5, which is negative 32. So that's why checking your answer with Desmos is often helpful, because it can help you catch little simple mistakes like that.